We're here with Navadeep, one of DevHeads resident computing experts. Hey, Navadeep, what makes designing a sensor interface with FPGAs so challenging?
Yeah, it's especially challenging for early product designers and developers because of the three particular issues which I would like to enumerate. So issue one being the difficulty in pivoting to a specific design implementation scheme, right? And issue two will probably be the navigation which a developer will face while going through the complexity and development time which comes with the FPGAs naturally. And issue three being, and major one is the development tool chain itself for hardware design implementation, which actually is simple as we're going to see.
Very good. Well, I think you prepared a demo for us. Can we jump in and take a look?
Yeah, I have a demo that explains IMU sensor interfacing through SPI protocol and running a C program for post-processing that data through FIR filter implementation. So this solution is around AMD Zynq 7000 SoC, which can be adapted to any target device. Let me go into the block diagram. So the whole story starts with the project definition in the Vivado flow. Then comes the block design where the user would choose the particular core which one would want. So in our case, it is the Zynq core itself. And then in the flow, next comes the synthesis where the design is laid out in the FPGA fabric and also the implementation phase. So generally the flow involves the HDC constraints file where you essentially map the pins of the FPGA to the design, and then the important part is the hardware exporting. So this XSA file is what links between Vivado and Vitis. So once you are over the Vitis platform project, you have this XSA imported, and then also domain, which involves the board support package and also the bootloader. Then comes the system project, which is all in the same flow, eased by the tool. And here you create like a general C program uh, running multiple threads or processes. And this finally gets implemented in the processor. Now we'll jump into the Vivado flow and look at how the design is put up. So looking into the sources, the only things we have over here are the block design and also the HDC constraints file. If you look at the block design, the Zynq core is the main. We would add it over here by uh, having multiple drop down to select different stuff. And then I also have PMOD libraries imported to here. So Zynq and also this PMOD are the two peripherals. Further, I added the I2C, GPIO, and the SPI interface as well. This PMOD is our sensor, which is on the board. So this is the inertial measurement unit through which we are getting the data. So in this flow, as we see in the block diagram, we have the design code, and then next would be to run the synthesis implementation, and then go over here and export hardware. So this would essentially give us the XSA file for the further Vitis flow. So jumping onto the Vitis, I have the platform project, the same XSA file imported, and then the filter.c and filter.h files. So these are the FIR filter implementations where I basically have the coefficients and then a ring buffer to uh, have the value flow through and implement the process. So in the pmod now.c, this is the main loop. I have the FIR filter update function, and then I'm printing the accelerometer X data, the X-axis data. So one is unfiltered and the other one is filtered. So this would generally be the flow. So now that we have seen the flow of the software implementation, we'll jump on to the serial terminal. So I'm selecting your port and you can see the data streaming in. So this is the raw data, the left one being the unfiltered and right filtered. And if I give a small deflection in the, yeah, to make more sense of this data, we'll jump onto the oscilloscope view. I'm going to set the scale and give some deflection. So you would see the filtered and unfiltered output of the FIR, basically firing action. So the output is the convolution of input and the impulse response of the filter. This being the stable data output from the sensor, I'm providing small movement to the board. So we see the red one having little wonky disturbances, and the green plot is basically the filtered one. So what FIR filter does is it's a digital filter implementation which convolutes the input data with the impulse response. We've seen the coefficient put over in the array. So based on that, the data is filtered. And yeah, that's about the live FIR filter on action.
That's awesome, Navadeep. Thank you so much. So, what are some of the next challenges that developers are going to face as they continue on their FPGA engineering journey?
Yeah, challenges can be quite broad. Further, we'll dive more into the topics and look at how to build a custom IP and RTL module through Vivado block design.
Very good. Well, if early to mid career professionals are interested in learning more about this or getting help with their FPGA based designs, where can they go?
Yeah, for help or to learn more about developing solutions with FPGA SoCs, or around, if you want to explore more on these examples, you can visit DevHeads GitHub repo, where all these contents will be put up open source. And also, I'm available at the rate NG25 over Discord, and feel free to ask anything about embedded FPGA topics.
Great. He's at NG25. I'm at TechieLou. And you can find both of us and all of our engineering experts in the DevHeads Discord server, which is linked to on screen and in the description below. We'll see you in the server.